So I've already done a very lengthy video explaining how you would compute the total number of subsets of a set. So now we're just going to reinforce our knowledge, right? So let's take a different set. Let's take the set B. What does the set B contain? Well, the set B contains the letters A, E, D, C, B. If you'll notice, I didn't write these in alphabetical order because the order does not matter. This is the exact same as saying B is the set A, B, C, D, E. Exactly the same, order does not matter. All that matters is all of the elements here are here, right? You find E here, D here, D here, C here, C here, B here, B here. And there's no extra elements here that you won't find here, and vice versa. There's no extra elements here that you don't find here. The size of these two is the same, and all of the elements here are also here, and all of the elements here are also here. But I'm going to stick with this notation here on the left because I don't want you getting comfortable with pretty notation. It's very important to, when you get to higher levels of math, to get used to letters meaning anything. Gravity doesn't have to be G, mass doesn't have to be M. They can both be L and Q, right? Same here, you don't have to get used to order. You have to get rid of that part of math and just focus on the actual theory and math behind it, the proof, the reasoning. Okay, so how many total subsets of B are there? Well, in the previous video, I told you this is the same as asking, if you take the power set of B, what is the size of this power set? The power set is a big set containing all of the subsets of B. So the size of it is simply going to be how many subsets are in the power set. And we found out that the answer to this is going to be 2 to the power of n, where n is going to be the number of elements in B, the number of elements of whatever set you have here. In fact, this could be 2 sets, right? This could be B union A union B, and so on and so forth, which we'll get to later. Anyways, how many elements are there in B is going to help us figure out how many total subsets of B there are. Well, what do? We just need to count them. So let's count them backwards because it's not going to matter. 1, 2, 3, 4, 5. There are 5 elements in our set that we're asking about. So we're simply going to say this is going to be 2 to the power of 5. Okay? Now I'm going to actually leave it here. Well, no, I won't. Because 2 to the power of 5 is something you can definitely compute. Because 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. To the power of 4 is 16, to the power of 5 is 32. So there are 32 total subsets of B, or the power set of B, the size of it is going to be 32. There's going to be 32 things if you write out the power set of B. 32 elements in that power set. Okay, now just for clarity, I am in fact going to write down every single subset of B. I'm going to write down what the power set of B is, just to more thoroughly convince you that this is true. So let's go ahead and do that. I think after a while, I have written out every subset of, I rewrote it alphabetically. I know I said I want you to get used to this, but when you are writing out every single subset, this makes it easier to see all of them. So we have the set of only ones, the set of only two, the set of pairs, the set of triples, the set of quadruples, and of course the set of all of them. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay. And I don't think I repeated any of them. So if I might have repeated this or this somewhere and I wrote it down twice, it wasn't on purpose. This is very hard to do, but the point is that this is the entire, let me make these brackets bigger so it's a lot more obvious of what this is. This is in fact the power set of B, is all of these sets. I drew this arrow to say it continues here. Okay. Fantastic. So as you can see, just increasing your set by 2, because before we had a set A with 3 elements, well now we just have 5, it's just an extra 2 elements. Look at how much more work, and this work gets exponentially bigger because of this, right? 2 to the power of 2 is 4, 2 to the power of 5 is 32. Imagine what 2 to the power of 10 is going to be. That's 2 times 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 2 is 10 times, right? So this gets exponentially larger. So just increasing one element is doubling the amount of subsets you're going to have from the previous number of elements you had. So this is just a formula that we're going to get used to when looking at the total number of subsets possible for a set to have. So hopefully this made it even more clear and really drove home the point why this is going to be a lot more useful, and you should not rely on writing out all the subsets, because that'll work from 1 to 3. After 3, maybe you'll do it for 4. Doing it for 5 takes 20 plus minutes, if maybe like 10 or 15 if you really practice it. But why go through this trouble? Why go through the trouble when we have this simple, easy formula that I'm going to ask you to just take as true? I've tried proving it. I'll need to read more into it before I make a video on that. But for now, we're just going to take for granted that this is true, that the total number of subsets of a set is 2 to the power of the number of elements in the set, or the size of the power set of the set.